Okay, now in this exercise, we will have a very complex scenario of deploying pods in geographical zones or nodes or hosts in different data centers. So I have this deployment with two replica in this loyalty namespace. There is condition that the first condition that this deployment must be only executed on uh, nodes in zone USS11. So this is toleration. If you can go to the node labels, the node in US1 has this label. The node in US2 has this label. So this is the node affinity. And those node affinity roles could be more details on could find more details on the Kubernetes documentation. Now, this affinity will be applied to the pod affinity. The pod affinity is that we will separate the two nodes, the two pods that will be never executed on the same node host. And to do that, we have to create a pod affinity. This pod affinity is required during execution and ignored during scheduling and ignored during execution. In case of host down or zone down, this condition, like the first one, will be ignored. So the node, the pod in this app royalty processor should respect this key. This key is called topology key. So when it is the pods should not have never the same host name on the host, and this will guarantee that only a pod will be executed in separate host. But in the last, we have a third condition. Default execution for control node is now scheduled. So Kubernetes will never schedule on this Kubernetes on this control plan node. Else we have to force him to schedule on this node. So we have to create a toleration, and this toleration will decay tolerate this condition. Control plan node who has this condition will be used for execution. So the control plan node here will be, so I have three conditions that are respected in this three criteria. Of course, I have also the first condition here that will create a container with the image below. So pod anti-affinity control how pods are distributed. Very important. Pod anti how distributed relative to other pods. So it asserts that are separated across different topology domain, nodes, zones, or regions for high availability. This is similar to VM anti-affinity role in VMware, with which condition my VMs will not execute on the same host. So in Kubernetes, we use the pod anti-affinity with the topology K and use hostname as the condition. So when scheduling pod 2, the scheduler look at the existing pod that match the label selector pod with the label the same label Apple YLT processor. So each matching node is find with the node that pod is running on. It gets the value topology K label Kubernetes hostname from that node. So it will extract from the label of the host name the topology key name. So any node with the same topology key is excluded from the candidate. Since Kubernetes host name is unique per node, this exclusively means do not place pod 2 on the same node already loyalty pod. So now I go to the next exercise. At the we can the, the third condition toleration the toleration is the operator used is uh, has a key a value a value and an operator well and effect the value are equal exists. Oh, equal is the default one, and it's match and effect all match. You must specify the value file. Exists also both of these toleration work with the match scenario. Option A equal operator. Option B exists operator. Now tent R3. Now schedule. So the now schedule pod without matching toleration will never schedule it on this node. Existing node are not evacuated. Prefer now schedule soft version. So soft version is the scheduler try to avoid this node, but it will use as last resort. There is a third condition that is now executed, and this is a hard evacuation. Pods without the matching toleration are evacuated immediately. New pods are also not never scheduled. You can optionally set toleration second to allow the pod to stay for a limited time. This is the so I can make description. Okay, can apply. We can see that the toleration events. She's fully assigned. Okay, poly. This is the pool. Started the container. So toleration is now scheduled. Pro- So we will get nodes with label. So the labels here are here. So the first node has the zone ES the zone ESB, and the worker also the zone ESI, and the worker has the now scheduled host name. Okay, are different. Okay, or tent we have to to get it from describe. The tent is here. The first tent, the first node, the worker one, the worker two has now tent, but the control has a tent. If you can see the pods, they are running. Look here, we have respected the conditions, and the pods are on two separated server, agent 0, agent server 0, and these ones are in zone 1. So we have respected the code. If you want to create, we can create another pod. I don't know if I have time to create it and test if this pod will be created on third node. We go to the next exercise. So we have another problem here in the same instance CKA 444, but with a new namespace Skyrot prod. Okay, the migration tip from legacy ingress resource to new Kubernetes gateway API for better traffic management capabilities. An existing ingress resource legacy ingress in the Skyrot prod namespace route traffic to few backend service based on host name. The gateway API CRD have been installed in the cluster. The gateway name plus scaroot class is available. Migrate the routing rules from the existing ingress to the API resources. So, uh, also this is a very exercise, very complicated exercise. You have to create a gateway named as Skyrot. This gateway will use the HTTP service on port 18. Then we will create an HTTP route named booking route skyroute. And then we will create another HTTP route for the check-in node route, booking route, and checking route, and all on the same namespace but with different ports. So the first step is to get the existing ingress, the legacy one. So the first exercise, this is the one. It shows the path, the booking. There is two roles: booking side or SH and check-in side or SH. So the booking is referencing to the booking service, and checking is to the checking service. So we can see that we have two services here. Skyroot prod. This two service. So the ingress policy is already existing. So now we want to create a gateway. This gateway will use the existing class, and this existing class will inherit configuration from this. So vi so this name Skyroot gateway, Skyroot prod It's this link on port 18. Now I will create the HTTP route by using this gateway. Okay, HTTP route. So it's HTTP route name in the Skyward pod. Parent reference is the already created gateway. Now we have the host name. The name that we already presented in the first in the gateway in the ingress legacy. So this gateway will use the booking seller host name and the booking service. We will create a second HTTP route. This second HTTP route will use the checking seller. So this HTTP route, you will use the gateway and the host name is checking seller. And well, it says get describe. Okay. We have two endpoints already created, and the ingress can apply موقف HTTP route and get okay. This is the gateway and this is the HTTP route. Now the HTTP route are clear and we can connect through the external now we can go to the next exercise. Always in the same cluster. In the scale staging, the scale Skyroad Airlines staging environment has broad naming. This pod is running on the Skyroad staging namespace. Can test. Okay, the question is this to extract lines containing the word error from the log generator pod logs and save them to the output. This is a pure Linux exercise. So let's go straight to extract lines from errors. So we need just to go to create two logs and forward the logs to external file. So logs, the name of the pod, the namespace, and grab only the errors. Now, the second question. Okay, let's see the contents of this file. Lots of. The second question is to extract to count the total number of error logs and save them to a second file. But this is also very non Linux. So if I have a file and I want to extract the number of lines, I will use the command this one wc count line wc -l. This is my error logs, and I will extract two. Sorry, I will extract. I will extract two here. wc-l. So I can cut how many line? 2000. There is another way to do is to use grep -c error. How many times the number errors has been appeared? The kind I will make can't do. So can't error can't do should be the same. Oh, I don't know, but there is little bit difference. Ah, because the number